Hello viewers, in today's class we are going to discuss one important problem from three-dimensional geometry related to the intersection of planes, right? So here we have to solve this problem in which we have to find the equation of a plane passing through the line of intersection of the planes x plus y plus z minus 6 is equal to 0 and 2x plus 3y plus 4z plus 5 is equal to 0 and perpendicular to a given plane 4x plus 5y minus 3z is equal to 8. So viewers, we have already solved and discussed a lot of problems related to intersection of planes in our earlier videos. So here once again in this session we'll solve this important problem, right? So here we are given two planes. The first plane is x plus y plus z minus 6 is equal to 0. So let us denote this plane by P1. So the plane P1 is x plus y plus z minus 6 is equal to 0. And the second plane is P2. We are denoting it by P2. So this is 2x plus 3y plus 4z plus 5 is equal to 0, right? And let us denote the third plane as P3. So P3 is 4x plus 5y minus 3z. Taking this 8 to the left hand side, we have minus 8 is equal to 0. So here what we have to do, we have to first find the equation of a plane which passes through the line of intersection of these two planes, right? Suppose we have two planes P1 and P2, right? And the equation of the plane which passes through the intersection of these two planes P1 and P2 is given by P1 plus lambda times P2 is equal to 0, right? So this is the equation of a plane which passes through the line of intersection of these two planes P1 and P2. So let us denote this plane by P. And here a lambda is a scalar and it is a real number, and we have to first find out the value of lambda with the given condition, and the condition is that the plane which passes through the intersection of P1 and P2 is perpendicular to this plane which is denoted by P3. So let us take the help of this rough diagram. So here P1 is this plane and P2 is this plane, right? And the line of intersection of these two planes P1 and P2 is given by this line, right? And the equation of the plane which passes through the intersection of P1 and P2 is given by this plane, right? So this is the plane P which passes through the intersection of P1 and P2. So now let us substitute the value of P1, that is x plus y plus z minus 6, and then we have lambda times P2. P2 is given by 2x plus 3y plus 4z plus 5 is equal to 0. So this is the plane P, right? Okay, so now let us rearrange the terms. So here we have x, here we have 2 lambda x. So we can write 1 plus 2 lambda x plus 1 plus 3 lambda times y. Then we have 1 plus 4 lambda times z, and then we have minus 6. Here we can write plus minus 6 and plus 5 lambda is equal to 0, right? So we have written this equation like this, so that the equation can be written in this form, that is ax plus by plus cz plus d is equal to 0, because we know that the equation of a plane is given by this first degree equation in x, y and z as ax plus by plus cz plus d is equal to 0, right? And the coefficients of x, y and z are a, b and c, and a, b, c denotes the direction ratios of the normal vector to this plane P. So now we have to find the value of this scalar lambda, right? Now see, we have the equation of plane P as this equation, right? So we have drawn another diagram here. So this is the plane P, and now this plane P is perpendicular to this plane, that is plane P3, right? So these two planes are perpendicular. That is, the plane P is perpendicular to the third plane, which is given as 4x plus 5y minus 3z is equal to 8, right? Now see, the normal vector to this plane P may be drawn like this, right? Suppose n vector is the normal vector to this plane P, whose direction ratios are given by a, b and c, which are here 1 plus 2 lambda, then we have 1 plus 3 lambda and 1 plus 4 lambda, right? And the normal vector to this plane P3 may be drawn like this, right? So this is the normal vector, say n3, and the direction ratios of this normal vector n3 are given by the coefficients of x, y and z, right? So the direction ratios of this vector n3 are given by 4, 5 and minus 3, right? So the situation is that this plane P is perpendicular to this plane P3, and this plane P passes through the line of intersection of P1 and P2. So P is perpendicular to P3. It means the angle is pi by 2, right? So when two planes are perpendicular, then their normal vectors are also perpendicular, right? So when the this plane P is perpendicular to the plane P3, then the normal vector should be perpendicular to the normal vector n3, right? And the direction ratios of this vector, normal vector n, are given by these three numbers, and similarly the direction ratios of this normal vector are given by these three numbers. So now we know that if the direction ratios of two vectors, say a1, b1, c1, and the direction ratios of the other vector are given by a2, b2, c2, and if these two vectors are perpendicular, then we have the condition a1, a2 plus b1, b2 plus c1, c2 is equal to 0. It means the dot product of these two should be equal to 0, right? And a1, b1, c1 are the direction ratios of this plane P, the normal vector n3, and a2, b2, c2 are the direction ratios of the normal vector to this plane P3, right? So now we have a1, b1, c1 as 1 plus 2 lambda, 1 plus 3 lambda and 1 plus 4 lambda, and a2, b2, c2 are 4, 5 and minus 3. So now substituting the values, so we have 1 plus 2 lambda times 4, then we have 1 plus 3 lambda times 5, and then we have 1 plus 4 lambda minus 3, right? So here we have minus 3 and this is equal to 0. So now we have a linear equation in lambda, so we have 4 plus 8 lambda, 4 ones are 4, 4 twos are 8. Then we have 5 plus 15 lambda. Then here we have minus 3 minus 12 lambda is equal to 0. So 8 plus 15 is 23. 23 minus 12 is given by 11 lambda, and here we have 4 plus 5 9. 9 minus 3 is 6. So 11 lambda plus 6 is equal to 0. So we have now lambda is equal to minus 6 over 11. So now we have obtained the value of lambda as minus 6 over 11. So taking this value of lambda to this equation, we can obtain the equation of the plane P, which passes through the line of intersection of P1 and P2 and perpendicular to this plane P3, right? So we have x plus y plus z minus 6, and then here we have minus 6 over lambda, minus 6 over 11. So we have 2x plus 3y plus 4z plus 5 is equal to 0. So this is taking or multiplying this equation throughout by 11. We have 11x plus 11y plus 11z minus 66, and then we have minus 12x minus 18y minus 24z minus 30 is equal to 0. So simplifying it, 11x minus 12x is minus x, 11y minus 18y is minus 7y, and then 11z minus 24z is minus 13z, and minus 66 and minus 30 is minus 96, right? Now multiplying throughout by minus 1, we have here all the terms become positive. So we have x plus 7y plus 13z plus 96 is equal to 0, right? So this is our Cartesian equation of this plane P, which passes through the line of intersection of P1 and P2 and perpendicular to P3. So here we can also express this Cartesian equation into vector form. So representing the vector r by xi cap plus yj cap plus zk cap, and we have a vector n which is the normal vector to this plane P, which is given by the coefficient of x, y, and z. So we have 1i plus 7j cap plus 13k cap, and we can now write this Cartesian equation as vector r dot vector n is equal to minus 96, right? So we can now write vector r dot, and this vector n can be written as I cap plus 7j cap plus 13k cap is equal to minus 96, right? So this is the dot product or the scalar product of vector r and vector n, right? So vector r dot vector n is equal to minus 96, which is the normal form of the equation of a plane. So from this vector equation or from this Cartesian equation, it is quite evident that the direction ratios of the normal vector to this plane P are given by 1, 7, 13, right? So these are the direction ratios of the normal vector to this plane P, which passes through the line of intersection of P1 and P2 and perpendicular to this plane 4x plus 5y minus 3z is equal to 8.